So we start. Okay, I just stand for a little bit that a car can take a seat, right, and take a break physically, even though he still need to work intellectually, right? You need to guide us if we do something wrong. And frankly, I'm just amazed at the car that you stand here already 3 days. But tomorrow will be 4 days. I think it's challenge for anyone. And 3 days because we did a practice on Monday before you coming. And he standing there, so it's just amazing. So basically, we will continue in this session the exercise that car learned out, and also he showed us how to do it. But the only difference, I think I will try to work on the cloud, that we can remember what John told us yesterday. And secondly, I think when we do the operation of the full modules, and kind of this had to be on the cloud. So just put that. But I will start from the beginning, that everyone can remember that how to connect to the cloud. From the beginning, but I already did some setup. So I think if you there's the things that you can continue with Windows, if you like, but you can also try the method of on the cloud. But I think everyone already downloaded the software and learned how to log in. So now I just do that. So I kind of, here you choose this, I just set up here and then load. This would be, this is another way to do it. Usually you need to put the host name, but I just put the IP address. That's kind of, I don't know, but for me, I thought it's better, but not necessary, right? Open, and just ask me login as a home. And I didn't know, I think John what set up was 2 presenters. One is for Carl and one for Dominic Tittora, but both did not use it. And Carl used the last student's account. So, and today I think I can use the presenter 1, start from there. You just continue with whatever you assigned to. I think presenter 1. Okay, I put my password. It's there. So this basically, we are logged on to the cloud. If you do a LS, there's a lot of things there. Because kind of, maybe me, maybe someone else worked here before, but today we just delete everything. We start from the beginning. So just RM, because you need to remove some folder, and with the option R, you are allowed to remove the folders and remove everything. And this wild card letter. And then we do another ls, nothing, and everything gone. So now we can do the normal things that we first download. I looked here, WS3, CPS3. These are things that John told us. I think you did that already. What was next? Cloudfish. Cloudfish classroom. .NET. Okay.
No, COX.
Yeah. Excellent. Kind of like this, right? Recursive. I think John told us that recursive is that when you copy a folder, that can't copy everything. You can also, just copy some of the files. There are ways, but today, we just do this. Hopefully it works. Yeah, this is everything. I think you did this. Now we do here, we, have the things we wanted. So here I put a README. I think this is typically on a Linux folder. When you go somewhere, always who created this for you or for himself, that README files, basically giving some guidance or explanation. So what are you expecting in this folder? Basically, I just put that, what John told us. Basically, this is how to operate. You have the login name, downloading, and things like that. After that, number 3 is the compilation. That's the real things that we have to start today. How to compile the models, how to run it. Basically, I should check input files. And we will do that. And check the control files that Carl already told us. Run the model, and then post-processing. And post-processing is the same, as Carl told us. Basically, if you forget one step, you can go back here. Look at the files, and then you basically know what to do. So the real folder is for EPA that Carl created for us and prepared, also the data there. When you go there, you are familiar with this. That SRC, this is a code where you do the compilation or compile the code. Input files, we will go there a moment later. And output, we learned that already. So now first we go to CRC. So here is the things. If you plan, so use this method on the cloud, and if you somehow you are not able to follow the steps, just raise your hand. Or smile, no, not smile, but wave your hand or make a sign, and that's why we have we call TAs, and Go Paul, Isabella, and Danny, they are ready to help. And we did a lot of practice. We did I think 4 times, so we know what to do. So basically now we are here. You do LS, all the content of this folder. The folder, we know that you have a WQM. This is executable, but this one was sent, a call sent to us. It may not work. It might be compiled in a Linux machine, Windows machine too. So the way we do it is just, remove it. Because we are using a new system, they just remove it. So now, it's not there. And the way you have to do some preparation, and now John helped this, created a compilation file, is a compile sh. Okay, is that you execute that command, you will compile everything. So basically, you can give a log of what's inside. Now this, also I suppose everyone basically know how to use it. Basically, this is the compilation command. It do a lot of things. And the good thing is that this command compile everything. Is that not only the model that I created WQM, but it also compile the post-processing program. So we don't need to worry next step. So we just do that. There are different ways to do it, but you can just simply type sh and this script basically, okay? And kind of not thinking, but I think working. So it's done. So to check if it's done or not, you can do another ls. The option TRL basically lists the files based on the data time they were created. So you can see the last one. Look, the last one, basically the green one, created today at 1858, and this universal time. Don't worry about the hour. If you look at only the minutes, it's the time on your computer. So you know that this just created by the command. So now the compilation is done. We can go up one level in the architecture of the folder. So basically, we can check here. It is supposed to move the here as well. You look at, there is another WQM. Basically, this is the copy of what we compiled. Why we move it here? Because we have to run the module here. And you have to run the module where the control file is located. And basically, this is the WQM-com and .mpt. So kind of, we kind of already, but maybe we do a little bit of check of the control files, what it does, and essentially how many years I want to know it run. And okay, we go up. I think Carl showed us this already. Basically, in this version, it's run only 1 year. Okay, it's run. This is the start time, and this is the end time of the simulation. Some of the exercise may need 10 years simulation. So I tend to, okay, we can do start with 10 years. Don't bother to turn back if we need. So you can keep the other one, I think like this. Okay, you put basically 3,650 days. This is the 10 year, right? And this we just run it. We run it, we call it the control run or the base case, because we want to do different scenario exercise. We want to compare. So if you modify something, you want to, here is just, learn what's the response and what's the result when you modify a parameter value or input files. So let's do that. Now just create and save. This usually I do colon X. I think that in the sheet I distributed, there is a few command on VI and also Linux. And this is the one we use the most. Okay, so I just do this, and you save your modification. If you don't believe, you can see also the data. The data changed, right? The time changed already. We just do a double check. It's there, right? We will open, it's not 365, but 3,600. So now we just quit without change anything, and now we run it. This step, we need to be careful, because this is on the cloud. The way you run it, you can run it in the way that you do on the Windows machine. Just call, the executable. But on the cloud, you can imagine, if everyone work on the cloud, we are, 20, you simultaneously use the same machine, basically, and maybe crash the machine. So we have to use the computation power or the computation node. A good thing is that when you do parallel computation, when we do the real models, we have to use the, parallel computation. So now there are a lot of things you need to prepare, but I think for this one, we just use Ethereum. I think Ethereum. Then you have an option N means how many core or thread you want to use. And for the 30 box, even on the Windows machine, it's just 1 or 2 minutes. So we just use one thread or CPU. Then you just give you the executable. Let's see, and finger crossed. Let's see it works or not. It works. But this actually not running on the master node that you do, VI or post-processing, but it is somewhere else in the cloud. Good things. And I think if you run it, you have to do that way that we don't crash the computer.
We're all in the queue.
Waiting for resources.
Nothing like supercomputing, right? Yeah.
Yeah, I don't know why mine just started immediately.
You hit return before any of us did. He was first, he was executed.
No, I think they have a...
No,
Yeah.
You're 75, I'm 76, so I hit return after.
Yeah, okay. Maybe.
Oh, you're ahead of us.
Yeah, maybe, but I think I do not remember the details. But the computation node, I think there are several, at least 8. Right? There are 8 and CPU that each one can ask one. And for the cloud we are using, for each node, it has 36. 36 via 20 is largely enough. But for this one, I do not remember exactly. Each node has how many CPU. But it's supposed to work. Is there any issue that...
72 is running.
72 is running.
I'm 75, so wait.
Okay.
73, 74, then mine.